Hi, we're in the unit on probability, and there are a couple of MyStatLab problems that you may have difficulty with. I wanted to go over some examples here. The first one you see is a table showing a group of people characterized by age across the top and gender. And what this contingency table or classification table says is, we have 16 men, for example, between the ages of 20 and 30, and 30 women between the ages of 31 and 60, and so on. So the first thing we want to do is total each column and total each row. That we have 50 total men and 54 women. And if we did everything correctly, if we added correctly, the sum of the columns should equal the sum of the rows. 3, 4, 9. Let's see, does it? 6 and 8 is 14, 4, 9. Yeah, it does. Okay. So now we can start using this information to ask some rather basic probability questions, like what's the probability you picked out a man? If there were 104 of these people in the room, and you picked out one at random, no bias, what's the probability it was a man? Well, there's 50 men out of 104, so it'd be 50 over 104, or in decimal form, whatever that is. Getting just a bit more complicated, you might want to know what's the probability that the person you picked out was either a woman or someone greater than 60. You notice this is an OR function, which means we add probabilities. We find out what's the probability we picked out a woman plus the probability we picked out someone greater than 60 years of age minus the probability that the person we picked out was a woman and someone who was older than 60. The reason we include this last term is because if we don't, then we're going to be double counting. So to find the OR probability, either or, we first find the probability we picked out a woman. There's 54 of them out of the 104. Add to that the probability we picked out someone older than 60. There's 11 of them out of 104. And then we have to subtract the probability that the person we picked was both a woman and someone over than 60. So that's 2 over 104. And since our denominators are all the same, we can add and subtract the numerators. We have 65 minus 2, so the probability is 63 over 104. That we picked out someone who is either a woman or older than 60. And when you do MyStatLab, be careful. They may want it in decimal form. They may want you to round to a certain number of digits. And so, be careful. Read the problem carefully. Now, the other situation is when we want the probability that the person we picked out is both, for example, a male and someone who is between the ages of 31 and 60. You notice there we have the AND function, which means you multiply probabilities. In this case, we don't, though, because each one of these cells represents an AND. The probability that we picked out someone who is both male and between ages of 31 and 60. Well, you see there's 25 of those who meet that criteria out of the 104. So those are pretty easy to pick out. One other probability that we want to cover is called conditional probability. Conditional probability. And we want to ask, what's the probability that we picked out a woman given that we picked out someone who was between the ages of 31 and 60? This vertical line represents the words given that. We're telling you that you picked out someone between the ages of 31 and 60. Now, knowing that, what's the probability that that person is a woman? Well, since we know that the person we picked out was between the ages of 31 and 60, we are now interested only in these 55 people here. And so the probability we picked out a woman is 30 over 55. That's called a conditional probability. Also want to talk to you about mutually exclusive events. Two events are mutually exclusive if their joint probability, that's the probability of A and B, that form, is equal to 0. So you see, the probability that we picked out a man and someone between the ages of 31 and 60, these are not mutually exclusive because they have a probability. Well, if, for example, we wanted to know what's the probability you picked out a man and a woman, well, with a single pick, it's impossible. Those two events, that probability is 0. So those two events are mutually exclusive. Okay, here's another one. It says someone gives you 12 to 3 odds. You can't roll two even numbers. That means you win $12 if you succeed, and you lose $3 if you fail. And they want to know the expected value of this game to you. And so, again, you're either going to win or lose this bet. And you're going to have two outcomes. And each outcome has a probability with it. So this is the kind of a table you have to set up for any expected value problem. If you win, you're going to win $12. If you lose, -3. That's a -$3. Notice that's a negative sign. Now, what's the probability of you winning $12? Well, what that means is that you roll, two even numbers, and you notice there are 9 ways of you doing that. So the probability of you winning is 9 over 36, or 1 over 4. And so the probability of you winning is 1 over 4. The probability of you losing, therefore, must be 3 over 4. So what we have, let me put it over here in case you can't see that. 12, 1 over 4, and -3, 3 over 4. That's the outcome and each probability. And so the expected value, if you recall, is the summation of each x times the probability of x, which, looks difficult, but really isn't. Just take each outcome. The first one is 12, and multiply it by its probability of happening, which is 1 over 4. And then add the second outcome, which is a -3 times the probability it happened, which is 3 over 4. So we have 12 over 4 minus 9 over 4, which is equal to 3 over 4. So what this is saying, and this is in dollars, remember, so the expected value of this game to you is 75 cents, 0.75. And if you played it many times, like 200 times, you could expect 200 times 0.75 to be your outcome. So those are two sample problems you're going to see in my stat lab, and I'm hoping that this will help you do my stat lab for this chapter. If you have any questions, email me afiduciatkaplan.edu.